So P saturation, what it's actually looking at is your total amount of phosphorus that we can release out of that soil system with just a root exudate. That's what H3A is all about, right? A root exudate. And what it's doing then is comparing that to the same extraction power or the same root exudation of that day of iron and aluminum, because iron and aluminum in a low pH soil is going to fix with our phosphorus, creating aluminum phosphate, iron phosphate, et cetera, where that plant can no longer recognize it as a pure phosphorus source to the plant as food. In a high pH environment, it's going to fix to calcium, right? You're going to create calcium phosphate. So that P saturation score is a great way to identify, is a pound of P going to act like a pound of P, right? Just like I talked about a nitrogen. Does a pound of nitrogen act like a pound of nitrogen? Well, it depends on the carbon to nitrogen ratio, right? Same thing with phosphorus. Is a pound of P going to act like a pound of P? Well, we have to understand first how much iron and aluminum are going to tie that up. And then secondly, how much calcium is there going to tie it up? Because the tie up factor is so large when it comes to phosphorus. You're going to get between 10 and 20 cents of every dollar that you spent on phosphorus into that crop. And the reason why is because it's the weakest kid on the playground. It's going to be bullied by every other nutrient in that soil system. So if you're not paying attention to the other nutrients in the soil system, you probably shouldn't even care about phosphorus, because it's not about the total amount of phosphorus sitting in that soil system. It's about what can we put in the available form that the plant can see and recognize as plant food.